Good evening, students. In last segment we have seen that what is projectile motion. So the projectile motion comes in the motion in the plane as it is described by the help of two axes. As it is just clear, it is the just path of the projectile motion which I have just drawn on the whiteboard. By the help of this particular figure, in this segment I am just giving you the idea that how we can just derive the path equation of this projectile motion. So from figure it is very clear that the trajectory of this projectile motion is of parabola shape. So we have to just find the relation for this particular parabolic path. Okay. So for that consideration I have taken the particular segment of this projectile motion, and that particular segment I have taken from this particular beginning point A, B and C. Okay. As we know, there is a combination of two components of the velocity. Let's suppose if any body is projected at an angle theta degree with respect to this horizontal. Okay. Let's suppose the initial velocity of any body is u and it is just making an angle theta degree with respect to this horizontal axis. So we can, as we know, that velocity is what? It is a vector quantity and we can just distribute its component along the horizontal direction as well as in the vertical direction. So it is very clear that in horizontal direction the velocity component u cos theta will act, and in vertical direction u sin theta component will act. So this u cos theta will assist the body to move in the horizontal direction, and by the help of this u sin theta component the body will move in an upward direction. So as it is clear that just see the path, at any particular path there is a two component of the velocity will be there. One is the horizontal component and one is the vertical component. Okay. So for the derivation purpose, let's suppose if we need to derive the path equation of this projectile motion, so I am just taking a particular segment ABC. Okay. Now we can, whenever it is required, so we can distribute the velocity component in two forms, one horizontal and one is vertical. Because if you are just considering A to B, so at particular B point, some horizontal component will be there by which it is just moving in a horizontal direction, and somewhat vertical component is also there by the help of which it is just moving in an upward direction. So we should just consider that which particular direction I am considering, and according to which we will use the particular formula of motion. Okay. So let's suppose here, let's see here, let's suppose the vertical distance from point A to B, that is y. Okay. And the initial velocity of any body is u, and this is the horizontal component u cos theta, and this is the vertical component u sin theta. Okay. From this point A to B, when the body is moving from point A to B, so it is moving in a vertical direction also, and in a horizontal component is also there, so horizontal motion will also there. So from point A to C, the horizontal distance I have taken x and the vertical distance I have taken y. Okay. So let's suppose the time taken by the body to reach to point B from A is small t. That I have just consider the total time taken by the body from A to B is what? T. So at particular t time the body will reach the vertical height y as well as it will reach to point C. So means in a horizontal direction it will cover a distance x, and at same time instant it will cover y distance in the vertical direction. Okay. So from the very basic law, as we know that vertical component of the velocity for the projectile motion will change. At all the instant the vertical component Vy will change, but the horizontal component will remain same. So as we know that u cos theta component will be remain same, so from very basics we know that distance is equals to speed into time. So normally let's suppose if I want to just relate this x u cos theta and t, so this x is equals to, x is the displacement in a horizontal direction, or you can say it's normally if I am just taking a magnitude, so I will use here x. So distance equals to what? The component of the velocity along the horizontal direction, and that is what? U cos theta, by the help of which it is moving in a horizontal direction. So whatever the motion you are considering, that component of the velocity you have to take. So for the horizontal motion, I have to take the horizontal component of the velocity, and that is U cos theta. So simply we can write, let's suppose from A to B, the time taken by the body is small t, that I have considered. So x is equals to U cos theta into t. This is from the very basics, because here there is a no acceleration, that is why I can use this simply formula. Okay, now we can just find the value of t also, that is t is equals to x upon u cos theta. Okay, and this can be given equation 1. This is for the horizontal motion. Now let's suppose if I am just considering a vertical motion for same point A to B. So if I am just considering a vertical motion, then I have to see the vertical component of the velocity. Okay, so if I am just considering vertical motion, you see here I am using the second equation of the motion, and according to which I am just writing here, and that is s is equals to ut plus half at square. It is our standard equation. Now if I am just considering the motion between A to B, so what is the vertical, what is the displacement? If I am considering a vertical motion, then I have to take the vertical displacement. So from this particular point A to B, if I am considering a vertical motion, so what is the vertical displacement? This one, and this is equals to what? Y. Means in a place of s I have to put y. Okay, just see here, u is the initial velocity, but if I am considering a vertical motion, then I have to take the vertical component of the velocity. So initial vertical component of the velocity is what? U sin theta. By the help of U sin theta, this particular body is moving in upward direction, so that component I have to take. So in a place of u, I can put what? U sin theta. Okay, and the time will remain same, so that is t. Okay, now see here plus at square plus half at square. The basic formula is s is equals to ut plus half at square, but what in basics of projectile motion I have explained that here the whole motion is considered only under the gravity, means the acceleration, whatever the acceleration will be there, that is due to the gravity only. So if any body is moving in an upward direction, so it is the case of the retardation, that is why I have to take in a place of a minus g. So simply I can write this formula in a modified manner, that u sin theta into t plus half, in a place of a I need to put minus g and t square. Okay, so our equation becomes y is equals to u sin theta into t minus half gt square. Okay, so this is our equation. Now I can put the value of t in this particular equation. So if you are just putting the value of t in this equation, so just see here that what we'll get. Just see on the left portion, I am just writing here, then y is equals to u sin theta, in a place of t I can put this x upon u cos theta. So you see here u sin theta into x upon u cos theta, okay, minus 1 by 2 g. In a place of t square I can put this value also from equation 1. So it is what? It is just x upon u cos theta of square. Okay, on solving you will get the result. You will cancel out sin theta upon cos theta, tan theta. So we can write x tan theta minus x square upon u square cos square theta. So it will be gx square upon 2u square cos square theta. So just see here, this is the relation between y and x component. Y and x component describes the particular location in the space of this projectile motion. Okay, so if I am just comparing this particular equation with the standard second order parabolic equation, that is y is equals to px minus qx square. This is the standard second order parabolic equation. Then just see here, in a place of p, this tan theta component is there. In a place of q, this whole component g upon 2e square cos square theta is there. Okay, so by the comparison of this particular equation, we are just getting that this is the path of parabola. So we can conclude in this manner that the path of oblique projectile motion is always parabola, and that only we have to prove that its path is parabolic. So whenever this question comes that you have to prove that projectile path is parabolic, so simply you have to just proceed by this manner. I hope that this video is useful. In next lecture, I will just give you some basic example related to this projectile motion. Thank you, class.